Hello, class. Welcome to Module 2, Lesson 15 of Eureka Math, all about what we call the Pythagorean Theorem. You'll need pages 165 through 175 of your workbook. You can rip those pages out. We're going to be working on those 11 pages today. The Pythagorean Theorem is named after a man named Pythagoras who lived in ancient Greece, and he liked working with angles and triangles. So today is all about triangles. Now, the road so far is we've been learning about angles in triangles. We learned that a triangle has 180 degrees on its interior angles, and we learned how to find missing angles in triangles using different types of rules, different types of strategies. Now, today, we're going to talk about sides, not angles today. We're talking about the sides of a triangle today. So make sure today you know the Pythagorean Theorem is all about the sides of a triangle. And it's not every triangle we're talking about today. Specifically today we're talking about right triangles. Right triangles. We're not talking about obtuse. We're not talking about acute triangles. We're talking about right triangles with a right angle in them. So not scalene, not isosceles, right triangles. So that's what we're talking about today. We're talking about the sides, and make sure, and you should remember the Pythagorean theorem only works with right triangles. Very important you know it only works with right triangles. So let's look at a right triangle so we can talk about what the Pythagorean theorem actually does for us. How does it help? So right here, this is my diagram of a right triangle. So here we go. I'd like you to copy this diagram into here. Let me make it a little bit straighter. I'd like you to copy this diagram into your notes so that you have it to look at throughout the lesson. You can see I drew a right triangle. You know it is a right triangle because right down here has a right angle in it. That little box right in the corner, that corner box means it's a right angle, means it is exactly 90 degrees. That is the symbol for 90 degrees. So it has one right angle, so it is a right triangle. Now there are other pieces of the right triangle. You see a triangle has three sides. You learned that in kindergarten. These two sides connected at the right angle are called the legs. The legs are the sides that touch the right angle. Important to remember that. The legs are the sides that meet at the right angle. The legs meet at the right angle. A lot of students get confused about what are the legs and what is the third one, the hypotenuse. You need to remember that right over here, I wrote it down in the notes, and you should copy it also. The legs meet at the right angle. So this is a leg A, this is leg B. A and B are for the legs. A and B are for the legs. You need to remember that. So we have the right angle, and we have the legs that meet the right angle. The third side of the triangle is this kind of diagonal line right here we call the hypotenuse. The hypotenuse is the side that connects the legs. So you see the legs are connected by the right angle and the hypotenuse. So they meet at the right angle, and the hypotenuse travels across to connect the legs. And we also label the hypotenuse C. So you see we go A, B, C. The legs are A, B. The hypotenuse is C. And the hypotenuse is always C. Do not ever label a leg C. Legs are A and B. The hypotenuse is C. Very important to remember because that is how Pythagoras wrote his theorem. The Pythagorean theorem tells us how the sides are all related. how the lengths of the sides are related. So what Pythagoras discovered that if you know how long two of the sides are, you can find the third one. The two sides can be put into an equation. The two legs can be put into an equation to find the hypotenuse. That is the Pythagorean theorem, where if you have a right triangle and you know two sides, you can find side number 3. And this is the Pythagorean theorem at the very bottom of my page. A squared plus B squared equals C squared. That means, remember, the legs are A and B, and the hypotenuse is C. So you take the length of the leg, you square it, plus the length of the other leg and square it. That gives you the length of the hypotenuse when you square it. A squared plus B squared equals C squared is how we find missing lengths. Last week we practiced finding missing angles. Today we're finding missing lengths, how the length of the sides. So we're going to use two sides to find the third one. Now I'm going to remind you about the important things right now. Important number 1, this Pythagorean theorem only works for right triangles. It only works for right triangles. Other important thing, remember the legs are A and B, and the legs meet the right angle. The legs meet the right angle, and the legs are always A and B. That's important thing number 2. And important thing number 3, the hypotenuse is this side that connects the legs, and the hypotenuse is always C in the Pythagorean theorem. Hypotenuse has to be over here. You cannot mix these up. It has to be in this order, and the legs have to be A and B. The hypotenuse is C. So the 3 important things: right triangles only. Legs are where they are. Know what the legs are. And number 3, know what the hypotenuse is. Now let's do a couple examples using the Pythagorean theorem so you can see how this works. So let's leave our notes for a minute, and go to page 165, example number 1, where it says, now that we know what the Pythagorean theorem is, let's practice it to find the length of a hypotenuse of a right triangle. So let's find the hypotenuse. So we are going to find, in this triangle ABC, there's the hypotenuse right there. It is C. Also remember to check, yes, it is a right triangle because it has a right angle. And then I'm going to label A and B for my legs. So leg A is 6, leg B is 8. And they actually do the math for us on this one. You can see right here, they write the Pythagorean theorem. I'm going to write it again just so you can see it bigger. You can see this is the Pythagorean theorem. A squared plus B squared equals C squared. So C is missing. Let's use A. A, remember, is 6. So we have 6 squared plus B squared. B is 8 plus 8 squared. C is still unknown, so we're going to leave C as a variable. Now we have to square. Now, in case you forgot how to square numbers, remember, an exponent means it's multiplied by itself. So this is 6 2 times. So we do 6 times 6. And then 8 squared means it's multiplied by itself twice. So 8 times 8 equals C squared. Remember, C squared we don't know yet, so that stays the same. 6 times 6 is 36. 8 times 8 is 64. Now we can add these together. 36 plus 64 is 100. So C squared equals 100. Now, we actually know what C is because 100 is a perfect square. So if I tell you that 100 equals C squared, you know 100 equals C times C. So what is C by itself? If C times C makes 100, well, you should know that 10 times 10 makes 100. So C by itself has to equal just 10. C by its, because 10 times 10 makes 100, so C squared is 100, but C, 1C, is 10. So that's the final answer, the hypotenuse. We can just write C equals 10. That's example 1. And they did that math for us. I just wanted to do it again and talk out loud about it. They gave you the answer here. But they did not give us the answer for example 2. So let's do example 2 together at the bottom of page 165. Let's check our important rules first. First, make sure it's a right triangle. And there's the right angle, so it is a right triangle. Check. Next, we find the legs. Now remember, there are 2 legs. And the legs are connected at the right angle. So these 2 sides next to the right angle, those are the legs. So this can be leg A, this can be leg B. It really does not matter which one is A and which one is B. You can do A or B wherever you want. I just like to go left to right because that's how I read, so I put A first and then B. But you can switch them up if you want to. So it's a right angle. We found the legs, and here is the hypotenuse C. And the hypotenuse is the one that is missing right now. That is what we are trying to find. The instructions say determine the length of the hypotenuse. So the first thing we need to do is we need to say, okay, so this is a right triangle. It has legs and hypotenuse, so we're going to use the Pythagorean theorem. So I hope by the end of the lesson you have the Pythagorean theorem memorized. If you don't, go back to your notes, and it should be written on your notes at the bottom right here. But the Pythagorean theorem is a squared plus b squared equals c squared. So now we just take what we learned from the diagram and put it in the equation. So a is 3, so we have 3 squared. B is 7, so we put 7 instead of b, so we have 7 squared. And c is still unknown, so we're going to keep the variable. Now 3 squared means 3 times 3, plus 7 squared means 7 times 7, equals c squared. 3 times 3 is 9. 7 times 7 is 49. So we have 9 plus 49 equals c squared. 9 plus 49 is 58. So we have 58 equals c squared. Now for example 1, we could find c exactly because 100, remember, is a perfect square. We know 100 is 10 times 10. But for example 2, we have a little bit of a problem just because 58 is not a perfect square. Like 7 times 7 is 49. 8 times 8 is 64. 58 is in the middle somewhere. So it's bigger than 7 times 7, and it's smaller than 8 times 8. So it's not a perfect square. It's like 7 decimals something. But we're not going to worry about what it is today. In fact, closer to the end of this school year, we're going to learn how to do this. This is what we need to call, this is something called square roots. So for today, you can just stop and say c squared equals 58. If you want to get fancy and work ahead closer to the end of the year, you can say c by itself is something called the square root of 58. This is a different symbol we're going to learn later in the year called square roots, and it is the opposite, the inverse of square. So if c squared is 58, then c by itself equals the square root like squared, square root, squared, square root. So c squared is 58. C by itself is the square root of 58. So you can do this answer or you can do this answer. Both of them are correct. I'm okay if you do this one for this lesson. But if you want to get fancy, you can do both. So those are the examples. Take a minute to look at your notes, check the examples, make sure you know how to do this, pause the video, and then unpause the video when we're ready to do a little bit of more practice with page 166. Welcome back, class. Thank you for pausing the video, checking your notes, checking the examples 1 and 2 on 165. Let's do a little bit of more practice, starting on page 166. We have 3 exercises on 166. They're all triangles, and we're going to use the Pythagorean theorem for all of them. So let's look at number 1 first. Number 1, we have a triangle ABC, and triangles have 3 sides, and they gave us 2 of the sides. First thing I need to check, if I want to use the Pythagorean theorem, it has to be a right triangle, and there is the right angle. So it is a right triangle. Now on this one, they tried to mess you up a little bit because they put the right angle up. If you look at both of the examples they gave you, the right angle is down the corner. So let me show you a mistake that some people are going to make. Here's what some of the students are going to say. They're going to say, here's A, here's B, here's C. Because in the examples, they think C is on top of the triangle. C is on top of the triangle. So you're going to have some students who say C is on top of the triangle. No, that's wrong. Remember, it's all about legs and hypotenuse. And the legs, remember, are connected to the right angle. So even if the right angle is up, the legs are still the ones connected. So this is a leg right here because it is connected to the right angle. This is a leg up here because it is connected to the right angle. Does not matter what way we spin the triangle. It only matters where the right angle is to find the legs. And because this one is not connected to the right angle, this leg is the hypotenuse. This side, not leg, is the hypotenuse right here. So remember always to find the right angle, because the right angle shows you where your legs are, and the opposite from the right angle is the hypotenuse. Now we have a right angle. We know where the legs are. We know where the hypotenuse is. And for this one, the hypotenuse is missing, so we are going to use the Pythagorean theorem to find it. And I have the Pythagorean theorem memorized, so I do not have to look back in my notes. You might want to look back in your notes to just double check. But the Pythagorean theorem is a squared plus b squared equals c squared. So for number 1, a is 3, so a is 3, so we do 3 squared, plus b, which is 4 squared, and c squared is still unknown. We're going to find that. So 3 squared is 3 times 3, plus 4 squared, 4 times 4, equals c squared. 3 times 3 is 9. 4 times 4 is 16. Still have c squared. 9 plus 16 is 25, equals c squared. Now we got lucky with this one because you should know your math facts, and you should know 25 actually is a perfect square. Something times something, c times c makes 25. And you know what c is. You know what times itself makes 25. You know that 5 equals c. Because 5 times 5 makes 25. So these c's are 25, but one c is just 5. So c equals 5 is our answer. And we know what c is exactly. For that one, we got a little bit lucky. For number 2, let's look at number 2. Number 2 is a different triangle, and the right angle is in a different location. It's not on the left right now. Everything we've done so far, the right angle has been on this side. But this time the right angle is over here. So find your right angle and then find the legs. Here's a leg because it's connected to the right angle. And here is a leg because it's connected to the right angle. And the hypotenuse is opposite from the right angle. So the hypotenuse is going to be C. And our legs that are connected to the right angle are A and B. And again, we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. And now we're going to plug in our values. I made A equals 8, so we have 8 squared. I said 11 is going to be the B, so we have 11 squared equals C squared. Now it's exponent math. 8 squared means 8 times 8. 11 squared means 11 times 11. 8 times 8 is 64. 11 times 11, I hope you remember your math facts, is 121. So 64 plus 121 equals C squared. So 64 plus 121 is 185 equals C squared. Now, you probably don't have your math facts memorized all the way up to 185, and you might be wondering, Mr. Baylor, is 185 a perfect square? And the answer is no, it is not. Let's see, I think 13 times 13 is 169, and that's less. 14 times 14, I believe, is 196. So this is somewhere in the middle between 13 times 13 and 14 times 14. So 185, we're just going to leave alone. We're not learning this yet. So you can say C squared equals 185, and that's a good answer. Or you can put C, 1C is the square root of 185. Both of those answers are correct. I will take either one, or you can write both. So that's number 2. We didn't get lucky like number 1. Number 1, we were able to find C exactly. Number 2, we had to keep it squared or write the square root. More practice. Number 3. Again, always find your right angle, because the right angle is going to help you find the legs. There's the right angle. So I know that the legs have to be connected to the right angle. So leg A and leg B are connected at the right angle. And hypotenuse C is opposite the right angle. So I have my legs labeled and my hypotenuse labeled. And it is a right triangle, so I can use the Pythagorean theorem. So I write my Pythagorean theorem, and now I'm going to use it. A was 9, so I have 9 squared. B is 4, so I have plus 4 squared. And C, we still don't know. C is what we're looking for. 9 squared is 9 times 9. 4 squared is 4 times 4. 9 times 9 is 81. 4 times 4 is 16. So we have 81 plus 16 equals C squared. 81 plus 16 is 97 equals C squared. Now, is 97 a perfect square? Can we simplify it even more? Well, let's think. 9 times 9 is 81, and 10 times 10 is 100. 97 is bigger than 81 and smaller than 100, so it's not going to be perfect. So it's going to be 9 point something is going to be the answer. So, but we're not going to worry about that today. You can just write C squared equals 97, or if you want to be fancy, you can write C is the square root of 97. Both answers are correct. Both answers will work for me. So hopefully you're getting practice plugging in these exercises. Let's do 2 more practice, the last 2 exercises, exercise 4 and 5 on page 167. We have a couple more triangles to look at. Triangle 4 is rotated around a little bit weird. But remember, it does not matter which way the triangle is rotated. You find the right angle. There's the right angle right there. So you know the legs are connected to the right angle. The legs have to be connected to the right angle. So find the right angle, and then find your legs. Step 1, find the right angle. Step 2, find the legs. Step 3, the hypotenuse is opposite the right angle. So we know where A, B, and C are. Now we can use the Pythagorean theorem. A squared plus B squared equals C squared, because we know where A, B, and C are. A for this triangle is 2. B for this triangle is 5, and C is still unknown. I'm going to start skipping the multiplication step. I'm just going to say 2 squared, 2 times 2 is 4. Plus 5 squared, 5 times 5 is 25. And you can start skipping that step too. You don't need to put the multiplication step. I just have these memorized, so I don't need to write it down anymore. If it helps you to keep writing it down, if you want, you don't have to anymore. You can still put in this step. So I'm okay if you only write the red. If you want to write the brown, you can write the brown. But please show me as much work as you do, at least show me the red, so that I can follow your work and know you understand. I do want to see your work, especially on the exit ticket, so that I know you are not copying your answers from anywhere. Show me your work so I know you understand. If you showed me the brown step, great. If you did not, that's okay. We all get 4 plus 25 is C squared. 4 plus 25 is 29. So now we have 29 equals C squared. Now, can we simplify that anymore? Well, let's think about 25. We know 5 times 5 is 25. We know 6 times 6 is 36. So 29 is somewhere in the middle of 5 squared and 6 squared. Let me do a little number line thing for you. We know 5 squared is 25. We know 6 squared is 36. 29 is somewhere in the middle. So it's bigger than 5 times 5, and it is smaller than 6 times 6. So it's going to be 5 point something times 5 point something. But we don't know what that is yet, and you don't have to know what that is yet, because I told you today you can just stop and say C squared equals 29. Or you can get fancy and say if C squared is 29, then the square root of 29 is just C by itself. Both of those answers work for me. So that's the answer number 4. Let's look at number 5. A different triangle, but there is the right angle. If the right angle is there, then I have leg A can be connected to the right angle, and leg B can be connected to the right angle. And the hypotenuse is the one that is not connected to the right angle. C is the hypotenuse, and it is right there. Now I am ready for my Pythagorean theorem. A squared plus B squared equals C squared. I have it memorized. I hope you get it memorized soon also. A this time is 1. B this time is 9, and C is still missing. Well, 1 squared is 1 times 1, so that's 1. 9 squared is 9 times 9, so that's 81 equals C squared. 1 plus 81 is 82. So, and that is as far as we can simplify, because the answer is, because 9 times 9 is 81, so 82 is going to be 9 point something times 9 point something. But today we can just stop here. We can say C squared is 82, or you can say C by itself is the square root of 82. I will take both of those answers. Those are the 5 exercises that we did to practice. Hopefully you understood them. Please pause the video now, go back and look at them, check your work. catch up with me, maybe check your notes and see how you're doing. When you're ready, unpause the video and we'll talk about your problem set and your practice for today. Welcome back, class. That was the end of our practice exercises and what we do together. Now I'd like to talk to you about what you're going to be doing individually today. Page 168, you can see, is the lesson summary. If you want to read it again, you can, or you can go back, watch the video again. Tells you what the legs are. See, right here, they call them the legs. And they have the hypotenuse. They remind you what the legs and the hypotenuse are. And they tell you about the right angle. And they tell you the Pythagorean theorem again right down here. So this is a quick one-page, not even one page, like a third of a page summary of today's lesson, if you need to see it again. Page 169 is your exit ticket. Just slide that away. We'll talk about the exit ticket at the very end. And then page 171 is your homework helper, where they actually have two examples to talk about. They give you example 1, example 2. They show you the work, and they tell you what they are thinking. So if you want the book's help, page 171 with the homework helper is a great source to be able to see a couple more examples. Your problem set is going to be on page 173, 174, and 175. So it's a 3-page problem set with 12 practice problems. I know it sounds like a lot, but it's just to make sure you, what we call, internalize the Pythagorean theorem and can practice it well. Plus 3 pages sounds like a lot, but because we have drawings of triangles, they only have like 4 questions on each page because they take up a little bit more space. And remember, I will have my answers on the online, linked on the Google Classroom, so you can do these 12 problem set questions. Check your answers with mine. So you can see that these are just like what we did in our practice. It's always determine the length of the hypotenuse. You are always finding C. You are always finding C. Today, you're always finding the hypotenuse. So as a reminder, let's do the steps. Step 1, find the right angle. Step 2, find the legs. Step 3, label the hypotenuse. And then step 4, use the Pythagorean theorem. That is the same 4 steps we did all in the lesson together. You just need to do those steps on these questions right here. So you're going to do, there's 4 triangles on page 173, just like the ones we did together. There's 5 triangles on page 174. Same exact instructions. And then you have 3 triangles on page 175. Same exact instructions. You're getting a lot of practice with the Pythagorean theorem. After you finish practicing with your problem set, go to page 169, which is your exit ticket. And this is what you're going to take a picture of and turn in to me on the Google Classroom. Page 169 is your exit ticket. Number 1, it just says label the sides with leg, leg, and hypotenuse. So just label leg, leg, hypotenuse. Can you find the legs? Can you find the hypotenuse? Just have to label. Number 2, find the length of C. So find C. So it's exactly the same. And number 3, find the length of C. So number 1, you have to label. And then number 2, you're going to use the Pythagorean theorem 2 more times to prove to me you know what you're doing. And remember, I do not want to see just answers. If you just have the answer, you're not going to get credit. I need to see your work. I need to see your work. In fact, I'm going to write it right here so there's no excuse. Show your work or no credit. Show your work or you do not get credit. I want to see what you do. I want to see your brain working on the paper. And that is the lesson. Once you finish the exit ticket, take a picture of it, turn it in on the Google Classroom. And tomorrow we'll work a little bit more on the Pythagorean theorem. We'll add a little twist to it tomorrow, but you really need to understand today to get tomorrow. So make sure you work hard today, do your best, have some fun with it, and I'll see you for the next lesson.